All right, so let's do number 6. The vector position of a particle varies in time according to the expression r being 3.00 in the I hat direction minus 6.00 t square in the j hat direction, and the units are meters for both of this, or maybe not that one. Anyway, the units are a bit messed up the way they wrote it here, but I'm gonna just fix it when I write them. So for part A, so you're given a vector, find the expression for the velocity and the acceleration as a function of time. Oh, that's pretty nice. All right, so the velocity vector is going to be dr to change of v. So that's going to be the velocity vector. So the velocity vector is going to be, just taking the derivative of this, is just going to be 0 components, 0 meters per second in the I hat direction, minus a 12 meters per second square times t in the j hat direction. So that's going to be the velocity vector. Now, if you take the derivative again, the change of velocity to respect to time, it's going to be the acceleration vector. The acceleration vector is going to be 0 meters per second square in the I hat direction, minus the constant acceleration of 12 meters per second square in the j hat direction. So that's part A. Pretty straightforward for you guys. So now the question is going to be asking, determine the particle's position and velocity and acceleration, which is going to be that. So I'm just going to write that down just as a side note. So the acceleration is always going to be negative 12 meters per second square in the j hat direction. I just like to write that. So determine the particle's position and velocity at 1 second. So the position is going to be at r, even though we're writing in terms of the unit vector, I hats and j hats, is going to be, wait, well, it didn't specify. I'm going to just write them both as vector. It didn't really specify, but whatever. So the position is going to be at 3 seconds is always going to be at a constant 3 meters per second. So it's always going to stay there. So that's going to be 3 meters in the I hat direction, minus, and you just put 1 here, 1 second times t, when t equals 1 second for all these vectors. That's going to be negative 6 meters in the j hat direction. So that's going to be that. I'll put the magnitude and the angle later. So I'm going to do that off the screen here, but that's going to be the position here. The velocity vector is really just going to be at 1 second. It is going to be 0 meters in the I hat direction minus 12 meters per second in the j hat direction. So that means that it's just going to be 90 degrees pointing downward in the opposite direction. So let's get those magnitudes. All right, so once you get the magnitude for this one would be 6.71 meters, and then the angle is going to be 296.6 degrees in the below. So the magnitude for this one is going to be 296.6 degrees. I don't know if they want it in terms of that, so I'm just writing that. And then for this one, the magnitude of here is 12 meters per second, and the angle is going to be 270 degrees if you want to write that down. I certainly do not. So if they're asking for the particle's position, I'm just going to write in terms of vectors. That's my final solution, because that's just the way I like to write these things. Anyways, folks, I hope you guys enjoy. All right, bye.